Hey guys, today I'm going to show you how to pass a 3G open root bend test. This is a fairly common qualification test for solid wire MIG welding. So I'm going to show you how to prep the material, how to do your fit up properly, and then how to weld all 3 layers of this weld on 3/8 plate to be able to pass a bend test every time. All right, so we have our 3/8 plate already flame cut to a 30-degree bevel, but now we need to clean up the mill scale, and we want to clean up the mill scale at least about a ½ inch away from the edge on the face side of the plate. We want to clean up this whole bevel without affecting the actual angle of the bevel, meaning we just want to clean up that mill scale and the dross from cutting without actually gouging into the material and changing the shape. And then because it's an open root joint, I'm also going to clean up just a little bit of this backside here so that we get good penetration on that backside as well. Okay, so we're going to go ahead and get started with the prep of the material now. Okay, so now we've removed the mill scale from the top side of the weld, the bevel itself, and the back side. So we've got it nice and clean because that mill scale will actually act as an insulator, and it'll just keep a little bit of the current from being able to go through. So we want to remove all that before we start welding. And then the next part of the prep is whether or not we're going to put a root face on our bevel. So that's at the very tip of the point of the bevel here on the root side. A root face would be if we put any type of flat or landing there. So that will be determined by just your personal preference, or sometimes it'll be in the WPS where they require a certain root face. But for this weld, basically you can leave it a knife edge, but then your parameters will have to be turned down, because if you leave it a knife edge on an open root, it's not going to take very much current to melt that away very quickly. So what I typically do is I put about a 30-second root face on there. So once it's all prepped and you have a knife edge, then you just take that to a pedestal grinder and run it back and forth a few times, or you can take a grinder at an angle and just put a very slight little flat on there, about a 32nd of an inch or so, no more than a 1/16. So I'm going to show you how I do that next, and then we'll go into the fit up process. Okay, so now we have our plates all prepped up, and we have a root face on there. The root face is no more than a 1/16 of an inch. And the other things that we need for our fit up is we need a spacer to space our root opening. And that's going to be 3/32 of an inch for this, is what I like to use. So I have some filler metal that I've cut to size just in this little V to be able to space that root opening. And then I also have some little tabs, just some scrap pieces to fit up to the ends, which will help keep that root from closing up as we weld it, and just give us a nice open root all the way through the joint. Okay, so we want to set our plates on a nice flat surface because we don't want a mismatch of the root side of this. So I just have it on top of another piece of plate so that it's nice and flat. And then I'm going to use my root opening spacer here to set that root for 3/32 of an inch. I'm just going to push these together and make sure that everything is in line. And then I'm going to fit up my tabs on this side. And the first thing I'm going to do is I'm going to fit up these tabs just with a light tack in 4 places on each side. And then I'm going to pick the plate up and I'm going to check everything and make sure everything's in line before I put in my heavy tacks, so that if I need to break it apart and adjust anything, any misalignment, any off opening on the root opening, I can do that without having to cut tacks. Okay, so let's go ahead and tack our tabs on there. Okay, I'm going to tack my tabs towards the bottom of the plate. And just a small tack to begin with. And once I put the tacks on one side, I want to pull out my spacer, because if I don't do it now, once I tack this, the shrinkage forces of those tacks will make it to where I won't be able to get that back out again, and it'll be a real pain in the butt. So we also want to, before we tack this side on, we want to check this root opening again, because it does tend to pull out on the other side a little bit from the distortion. So I push those plates back in again, and I like it to be real snug on my filler on both sides. Okay, so now I'm ready to tack this side. I'm actually going to flip this around, make it a little easier to see. I'm going to check my opening again, just because I moved that around. I'm going to tack this other side. Okay, so we got our light tacks in on our tabs, and before we put in some major like stitch weld tacks, we want to check everything, and we want to make sure our alignment is good on the back side here, because if we have a misalignment of one of the plates, then it's going to be more difficult to get the penetration that we need on the back side on one side of the plate. So I'm going to check the alignment here. I'm just going to take a look at everything and make sure that it's exactly how I want it. It's fairly straight. The plates are on there fairly straight. And then I'm going to put 1-inch tacks on both sides of these tabs. And this is important because this will hold the joint open as we put in our root and keep it from closing up on us and changing how much penetration we get. Because when we're done, we need full penetration all the way through the root of this joint in order to pass this test. All right, so now we have it all tacked together. And again, once I was sure that the fit up was all good, then I put in these 1-inch stitch welds, and I did that on both sides of these tabs, on both sides of the plate, okay? So that way it won't close up as we're welding it. So now we're ready to weld. So we're gonna get this fit up in the 3G vertical up position, and then we're gonna weld the root pass. Okay, so now we have our plate in position for our vertical up weld here. And one thing I wanted to talk about is body positioning and just overall comfort. So we really want to spend some time before we start this and make sure that the plate's at the right height to where we're going to be comfortable throughout the weld, each weld pass. And we're also going to be able to see that weld pool throughout the entire progression here. So you can see I have my plate set up here, and I have it at a height to where I can start off at a comfortable position and I can end at a comfortable position. So we wouldn't want to have it too high to where we end up, having to get on our tippy toes to be able to see that weld pool at the very top. And just overall, we want to be in a comfortable position all the way through. So I'm also I'm cheating a little bit with my trusty Rodcan armrest here, so that, I can have my body nice and planted against the table here as I progress through my weld. So that's really, really important, because if you're not comfortable, you might as well not even, pull the trigger, because you won't get the penetration that you want on the back side. You won't get what you want out of your weld if you're not comfortable. Okay, so let's go ahead and give it a shot with the root pass. At this configuration, in terms of my 3/32 root opening and my maximum 1/16 of a root face, I'm at 17 volts and 170 wire feed speed for my parameters on the root pass. And what I'm going to do is I'm just going to do a very slight side-to-side motion, focusing on that root opening. And the side-to-side just kind of breaks up that base material, breaks it down so that we get nice penetration on the back side. And the other thing that's important is not using too much of a push angle on this root. So for our other passes, we're going to transition to a slight about 20-degree push angle. But for this root, in order to not get any whiskers coming through the backside, we want to be right at 90 degrees and stay in that puddle and not get ahead of it. Okay, so let's go ahead and give it a shot. Okay, so here's the root side of my plate. And you can see that I got full penetration all the way through. I had a little variation in my root opening. You can see on these ends it was more open, so I got more penetration. And in the middle it got pretty tight. So I really had to focus in this portion of it right in the center and try to keep my heat right in the center of that root opening to get it to penetrate through. But ideally I want more penetration than this. This is a little questionable for the bend test, so I guess we'll see when we get to that point. But I would much rather have penetration looking like this all the way through. But in fitting up our plates, we're always going to have some variation with each plate, so sometimes we have to make some variations in our technique as we're welding in order to get the result that we need. So I think that this will be okay, but I guess we'll see. That's what the bend test's for, right? So we'll see what happens. All right, so now we're going to move on to our fill pass. All right, so for my fill pass, we want to make sure we're using this Z-weave pattern and we're pausing on the edges and letting it fill up so that we have a nice flat layer in there. And we want to leave about a dime's thickness left over to the edge of the bevel for our cover pass. And if we get the proper stack up of each one of these layers, it'll make it a lot easier to get a cap pass, which is nice and smooth, that's not too high over the 1/8 inch maximum, and won't have any underfill in the center. So on this cap pass, our maximum height is 1/8 of an inch. So this all looks good in terms of our height. And one thing to put into your technique in order to get a nice flat cap pass like this is to go fairly quickly but smoothly across the front of the bead and then pause on the sides. And it's really important to pause on those sides long enough to fill any undercut. And that way it smooths out the reinforcement all the way across the face rather than having a high center and low edges. So that way it's nice and smooth. Also, watch your Z-weave pattern as you go side to side. Make sure that it's close enough together to where it's all bleeding together and filling in and tying in. If you go too far ahead, meaning you advance too much on each part of your Z-weave, then you'll leave some little areas in between that can give you trouble on your bend test. So this is pretty ideal for what we'd like to see on our cap. Okay, so now we're going to do the layout for our bend test. And the code says that we'll need to find the center line of our plate. And we'll go 1 inch out from the center line on each side, and then we'll have 1.5 inches face and root bend test specimen. So we're going to go ahead and find the center here. These are 8-inch plates. So we're going to make our line at 4 inches for our center line. Okay. And then we'll go 1 inch out from that on either side. Make our line for our inch. Okay. And then we'll go 1.5 inches out for our face and root bend specimen. So there we have our layout for our face and our root specimen for a bend test. And then we also want to keep this center section. The code says that if we have a corner crack, we may use the center section to retest within certain acceptance criteria. So we always want to hold on to that until after we do these bend tests. Another fun thing that we can do, if it's a certification or just if it's something that you're testing your welds on, if you're in school or something like that, is keep this center section so you can actually see your weld, because you're going to prep these 2 bend specimens. You're going to grind down your weld on both sides. And then if you still have this center section, you can take your 2 bend tests and tack them to it. And it's sort of a fun little trophy or memento from doing your weld test. All right, so let's go ahead and we'll cut these on the track cutter, and then we'll get to the prep section for our bend test specimens. All right, so we have all our pieces cut now. We're going to take the 2 end pieces here, and we can discard those and get rid of those. And that leaves us with our 2 bend specimens, one for face and one for root, and then a 2-inch center section. So we want to hold on to this 2-inch center section because the D1.1 code says that if you have a corner crack on your bend test, if you have a corner crack coming from the corner of the bend test that exceeds 1/4 inch and it's not from visible slag inclusion or fusion type discontinuity, that you can actually retest from the center section. So it's a good idea to hold on to that until you're sure that you've passed the test. And then one thing I like to do is if you're doing a qualification, a welder certification, especially if it's like your first one or something like that, you can save the center section that has your weld on it, visible on it, and then you can put your 2 bend test samples on here and tack them to this like a little memento from your first test, if that matters to you. And that way you can actually see the weld, and then you have your 2 bend tests. Hopefully those are free from any type of discontinuity that shows up there. And then it's something that you can show people and, kind of a memento, like I said. So, all right, so we're going to go ahead and we're going to prep these now. And what you want to do to prep these is we're going to remove the weld just down to the base material, and we're going to grind it in this direction. So that means that we want to take our grinder, and because our grinder rotates this way, we want to grind this weld down in the center just until it's flush with the base material. We don't want to go any further than that. And that way our grind marks will go lengthwise. And that's important because we want those the graining and to go lengthwise there, so that as we bend this, it doesn't open up. That can give it some, ability to, those striations going the opposite way might, spread out as it's bending. At least that's what I've always been told. So we're going to grind it in this direction so that the grinding marks go lengthwise. Once we get the face weld flush with the surface, and the root side flush with the surface. Then we're going to clean up these edges, and we're going to break these edges so that we have a nice radius, no more than an 1/8 inch radius. And that will also help our bend test. We don't want any sharp angles anywhere that can be, you know, areas where cracking can start to propagate. So we want it all nice and smooth and rounded off for our bend test. All right, so we're going to go ahead and do that. I'm going to use a stone first. This is what I like to do. I like to use a stone to remove the bulk of the material, and then I go to either a flapper disc or sandpaper like this to do like a polish once I remove the material. And that's just right in the center. We don't need to remove the mill scale all the way out to the end. We just want to remove that in the center so that we can see on both our face and our root bend specimen, we can see that weld very clearly. Okay? All right, let's get started on that. All right, so now we have our pieces all prepped. So again, I've ground down till it's flush with the base surface on both sides, root and face side. And I've rounded the edges. So I broke the edges up to 1/8 of an inch radius on all the corners. And that's really important for our bend test so that we don't get corner cracks. So we want to make sure that we clean up those edges and break them. The other thing that I wanted to mention is if there's any low spots that show on the face or on the root, you know, wherever you're grinding, just go to flush with the base surface and then stop. If you continue to try to chase these low spots, which pretty much they always have a low spot there next to the weld, you know, from that base metal kind of turning up and the distortion of the weld, you're always going to have those low spots, so don't chase those and end up with, you know, a 1/4 inch plate instead of a 3/8 plate, because that can be, if you're doing a certification and they see that, you know, the center of your test coupon is way, way thinner than it should be, then that can be grounds for a fail just in that. So, you know, just make sure, just stop. It is what it is. You can't lie about, you can't cheat the bend test. That's the beauty of mechanical testing. It is what it is. So at that point, just prep it the way that it should be, and we'll see what happens with the bend test. So let's go ahead and do that now. All right, so we'll do root side first. All right, so here we have our root side bend test and our face side bend test. And you can actually see the weld metal pretty clearly if you do a good polish job. You know, it has a different grain structure than the base material, so you can actually see it pretty clearly as it stretches out there in the bend test. And the D1.1, the AWS D1.1 code says if any discontinuities open up in the bend test, they can be no more than 1/8 of an inch measured in any direction. So we really didn't have anything that opened up on these bend tests. On the face here, there was some low spots that you can kind of still see, but those aren't really discontinuities. They're just low spots, and they just kind of stretch out a little bit, but they actually don't open up to reveal any type of discontinuity. So that's what we're looking for, is something that opens up, either, you know, lack of fusion, porosity, if it was a you know, a flux type process, maybe a slag inclusion or something like that. But these are pretty clean, so this would definitely be a pass. So now we can take these two bend tests, like I was saying before, and we could actually tack them onto our center section here. And we have a nice little memento of our bend test with our two specimens and a sample of our original weld. All right, so there you have it. There's how to pass an open root 3G MIG test every time. That's how you can prep all your pieces to pass that bend test and get qualified in this process. So hopefully you've enjoyed this video. It'll help you out. And don't forget to like and subscribe for more videos like this.